Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Here are the homework solutions for homework number 1, starting with exercise 1. So for this one, you have to print out 4 lines of text with, oh, what a happy day. Oh, yes, what a happy day. So starting with the first line, we need a preprocessor, which is going to be IO stream. If we're going to be outputting information into the console, that's the first thing that we should be doing, right? Because we're going to need that for the cout object. So going into the main function, we have cout and the insertion operator to add to the stream. And then we have oh what, so we're putting in a string, we're adding it to it. And then we add the nl to let the program know that we're not outputting anything else to the stream, and we end that statement. So with nl, that's what allows us to start that new line. We go again, cout, happy day, and then nl to end that line, and then so on and so forth. Exercise number 2 is about spotting the errors. So we had here the comment, the multi-line comment was done incorrectly. So we started this way and we close it this way. If you don't close it, you'll comment everything out, all the other lines. And I think we had it backwards basically, so it wasn't opening it correctly. We were using the incorrect module name, and we were forgetting to use namespace. So the compiler needs to know which namespace we're using. We have to make sure that we specify the arguments bit here for the function, starting with the opening parenthesis and the closing. So even if we have no arguments to declare, we still have to have this in our function. That is just the body of the function, or the structure. So then in here, we have our actual code. So let's see what's wrong here. This statement was not finished correctly. We had a quotation mark, and without a quotation mark, then the compiler doesn't know that that statement has ended. Okay. For the next one, we had these arrows facing to the right, which actually makes it the extraction symbol, or the extraction operator. And it's for extracting data, so for entering data into the stream, rather than just outputting it, so displaying it essentially. So we need to make sure it's facing to the left if we're going to be using it with cout. This bit here was encapsulated in a string, so we had quotation marks on both sides, and that's a problem, because then it's just going to try to add it to the output stream as a string rather than actually reading that it's the end line, right? Here we had single quotation marks, which is not how you build this string. You have to use just the double quotation marks. And then in here, we had a full stop rather than a semicolon. And finally, this was a parenthesis rather than a bracket. Needs to match basically what's up here. Now for exercise 3, let me take you to the editor so I can show you what that looks like. Here we are, we have our code, and I want to make sure that you understand why we're getting that result, basically. And the reason we're getting that result is because you have the main function, which starts with dear reader, have a, and then you go into the pause function. Now the pause function is what adds in the break. And then you have it goes back, and you have the exclamation mark, right? So if we were to change this to, let's say, pause, and we run that again, it actually changes the break. So we're getting this bit coming from the main function, and then this bit coming from the pause function, and then followed by the exclamation mark. These are the solutions to homework number 2. So let's go through them, starting with exercise number 1. So this is where basically you have to print out the sizes of each fundamental data type, but obviously not typing out the values yourself, but having the machine calculate them. So let's go ahead and see that in action. And let me take you to the editor so you can see. So here we are. We've got the IO stream at the beginning, just our preprocessor, because we're going to be dealing with output, our namespace, and then our main function. And really the only bit that's new here is that when we're printing out the name, we're printing out beside it the actual maximum memory size for that fundamental type. So we're doing that using the size of function. And to use it, we just got to put in the name of the type inside, and then it's going to print out, it's going to return that value that we need. So the size of that data type in bytes. So let's go and run it and just make sure that works. And there you go, exactly as expected. So you get char1, char2, int4, and so on and so forth. So let's go back then and look at exercise number 2. So for exercise number 2, you had to print out a special text sequence using a bunch of special characters and laying it out in a very specific way. And the only way you could get around and actually make it happen is if you were using escape sequences. As you can see here, we've got a ton in the solution. So let me show you what that's going to look like once we run it. So we have here our main function, and we start out with cout, and then our extraction or our insertion operator. And notice how we are only using one cout object. So that's something that we can certainly do. We can borrow that same one rather than have to keep repeating it all together. And we start with the first line of the string, right? And we're having 2 line breaks by using the \n, and then we have a tab, push it over. Then we have here again on the next one 2 line breaks, 2 tabs, so pushing it over a bit further. Some quotation marks that have you can see here the escape symbol for the quotation marks, \/ quotation mark. Then we have the same, but an additional tab. And here we're actually escaping the \\. So we're having a \/ in there. Then for the /, we don't need to do anything because it can be it gets automatically included. We don't need to use an escape sequence at all whatsoever. So let's run that and see what the output is like. Okay, and there we are. So as you can see, we did all that with just one cout object and a lot of escape sequences. Now we move on to exercise 3. And for exercise 3, you had to specify which variables were initialized incorrectly, or which constants. So the first one here that we have is int a 2.5. The problem being 2.5 is not an integer value. The next one here, this constant, we actually haven't initialized it at all. We've just declared it without giving it any sort of value, which it's kind of pointless at this point. The next one being char said, and then we're putting in 500. Obviously, the value for 500 is way too large to fit in it into a single character. The int big equals 40,000. That goes over the maximum of 32,767 on 16-bit system. So we have to be mindful of that. That depends on the system that you're using. Then double, and then we name it keys. So in this one here, we cannot use this symbol in the variable name essentially. So it's it has to be alphanumeric. And then finally, for the float value, the accuracy can only be 6 digits. Okay, so moving on to exercise number 4. This one's all about defining and initializing variables. So we have to define doubles, add them up, and then get the difference. So let's go ahead and see what that looks like in the actual development environment. Okay, so here we are. And we start out defining our floating point variables. The first one, as we needed it to be, the second one, y, and then we can actually create a variable to store the result of the sum. So it can be x plus y, and that's going to store the sum of that. And then when we go to print it out, we can actually use that sum variable to display the result. Another thing we can do is actually, for example, when we're doing the difference and we're subtracting them, we can just put in parentheses the actual calculation, and it will actually complete the calculation within this bit and then just return the value, and it'll get printed right away. So as you can see, if you had to display this difference multiple times, you would have to repeat that calculation, whereas you can just define it once. Example, x minus y, and then you can just print it out like that. So that's another way that you can do it if you wanted to, just a slight variation. But let's go to the original and let's print it out to see what that looks like. Okay, there you go. Okay, guys, so let's go over the solutions to homework number 3, starting with exercise 1. So because these ones deal with quite a bit of arithmetic, I'm actually gonna pull out the calculator and show you how it's done manually rather than leaving you with just the number and wondering how we got there. So starting with exercise 1a, we can do 3 divided by 10. We'll do 0.3, but we'd actually store that as 0 because we're dealing with integers, okay? Next one is 11 divided by, modulus 4. That one is 3. Next one is 15 divided by 2.0, 7.5. Now, this one we can actually store as 7.5 because we are subtracting by a double, okay? So the result is going to get stored as a double, which is the larger of the data types, essentially. For 1D, we would do 4 modulus 5 plus 3, that gets us 7. E, we can do 3 times 7 modulus 4, 1. And then lastly, 7 modulus 4 times 3. Okay, that gets us 9. Let's look at the results there, and there you go. So that matches. Okay, so moving on, we have exercise 2. How are the operands and operators in the following expression associated? So we would do -4 times I, okay? And then we would do 6 modulus 4. We'd have 2 results, and then you would subtract this side from this side. Now, bearing in mind, you do have the incrementation here, but because it's after the I, you deal with that after. So it's not really relevant at this point. I'll show you what I mean with this example. What value will be assigned in part to the variable x if the variable I has a value of -2? So in here, we can do -4 times 2, okay? That would give us 8. Now, instead of incrementing I to 3, we use the original value because the incrementation is only being done afterwards, okay? So at this stage, it's not really relevant. If we were to use I later on in a further line in the program, then it would be relevant. But for now, it's not really something that we're dealing with. So if for example, the plus plus was before the I, then you would increment immediately. So we have 8 at least on one side. We've determined this side. We can do 6 modulus 4 gets us 2. So 8 minus
Thanks for watching. Please like and share this video.
Minus 2, and we get 6. Let's check it out. And there you go. Value 6 will be assigned. And here are the parentheses exactly as we were discussing. So you do this side first. You can do this side, get this answer. And then you subtract both. Okay? Okay. Now let's look at these expressions and calculate them to true or false. So the first one here, we have x minus 10 and x equal to or larger than or higher than -1. So this one, they both have to be true because we're using the AND operator for the expression to end up as true. So because x is 7, this bit is true, and it is larger than -1, so that's also true. So this one would be true. On the following one, we have not x, so this actually would, this exclamation mark would actually do the opposite. So if we put 7 in there, it would give us true. But because you have the exclamation mark behind it, it would actually do the opposite and give us false. And right away, you can stop looking at the rest of the statement because we're using the AND operator. So if one side is false, then the rest doesn't really matter, right? We look at C, and for this one, we have x plus plus is equal to 8, okay? Or x is equal to 7. Now this one is false because in the first bit, you would look at 7, right? Because the plus plus is after the x, we're dealing with the original value for now, okay? So we'll be looking at, okay, so is 7 equal to 8? That would give us false. So we know this side is false, but we still continue looking at the rest because we're looking at the OR operator. Now, another thing, when we get to this side, because we've incremented, x is now 8. So this would also be false. Therefore, we have true, false, false. And we can now look at exercise number 4. So this one can be a bit tricky because we have to go through it and try to understand the output and why we're getting a certain output. So let me take you to the development environment. Okay, so here we are. We start out with cout and then bool alpha. That just basically turns the zeros and ones to true and false, just so it's a bit more visually appealing. I guess it's a bit easier that way. Let's see. So we start by defining this Boolean res and an integer 5, okay, as y. So in this first bit, let's see if we can determine the result of this this statement, okay, this evaluation. So we start out with 7, that would be true. And then we have the OR operator. So this would be true right away, okay? This actually would give us false, but the interesting thing here is that because we're using the OR operator, as soon as it gets to true, it doesn't care about the rest. So this assignment, and just to make this clear, this is not checking if y is equal to 0. This is actually assigning 0 to y because it's only one equal sign rather than 2. But because it's already got a true here, it doesn't really care about the rest and it's going to skip it altogether. So when we actually check the result of res here, that's going to be false. Actually, sorry, that's going to be true. But when we check, because we've got the true from the 7, but when we check the value of y, if you just look at this right away, you might think that it's going to be 0, but it's actually going to be 5, because when we're dealing with the OR operator, as soon as we get a true, it doesn't care about the rest. It's just the compiler just cares about being efficient and being fast. So it's gonna skip that altogether. Then we define 3 integers and we set them all to 0. Okay, So A, B, C. So in this line here, in this statement, we are using the OR operator, okay? And we are incrementing A to 1. So right away, we increment A to 1. And you might think that we are also incrementing B and C. But once you realize that we have the OR operator, once we get a 1 here, that equals true. And because that's true, this rest gets ignored. So B is still going to be 0, C is going to be 0, and that's what you're going to see printed out. So then we go ahead and we reset those again to 0. And now we're running a different evaluation. Now we're saying increment A and increment B. So either this side is going to be true, or this side is going to be true once we increment C, okay? And once we get to this point, it's going to do both, okay? Because it has to check if these two are true, right? So this is going to go to 1, that's going to be true. This is going to go to 1, it's going to be true. And when it gets to this bit, it's not going to care about this, because once we have true on the left side of the OR operator, because that's all it needs, it's going to ignore the rest. So this is going to be true, and then A is going to be 1, B is going to be 1, but C, because of that, C got ignored, unfortunately, that's going to be 0. So it's just something to bear in mind when you're dealing with OR operators. As soon as you get a true, it doesn't care about the rest. If you're dealing with an AND operator, as soon as it gets a false, it's not going to care about the rest, okay? So let's run it and see what we get. And there you go, exactly as we expected. As I was telling you, we have this one's true because of the 7. Then the value of y, you might have missed it and thought this was going to be 0, but it's actually going to stay as 5. And then this first rest here, that's this one, okay? That's gonna be a true because this A gets incremented to a 1, and that's gonna equal true. Then only the A will get set to 1. The B and the C will get ignored in this line because of the OR operator. And then the same for the following line, except now B is also getting incremented. So I hope that helped in terms of understanding this bit. You can always just, it might be a bit too much to take in at first, so just break it up and do this first bit first, and then do the second one, and then the third one, and by the end of it, hopefully you should get it.